At this point, I have presented a pretty workable grounding in MaxScript, enough to allow substantial scripts to be written. To round things out, I will now present several rather larger scripts that reinforce this grounding and show a number of common coding patterns you should be able to use for your own scripts.
First, another example of geometry creation. In this case, a tool to make chains. It takes a controlling spline curve and builds an interlinked chain along the curve. Let's run it first. This time I'm going to use the Max Asset Browser for opening and running the script. I'll navigate to the script folder. Here it is. I can double click on a script to open it, as you see here. I'll put it aside for the moment, or I can drag it onto the viewport to execute it. And here you see it's opened the tool. The tool displays a dialog with two groups of controls. One to allow a controlling curve to be picked, another to set chain link parameters. So I can click the pick button and pick objects in the scene. And you'll notice that it only allows me to pick curves. I'll pick this one here. I can change the link diameter to say 10 and the wire color to say mauve of some kind. Okay. And then press Create Chain and I get an interlinked chain following the spline. Let's look at the code. There's a rollout definition containing the UI specs up here and handler functions down here to implement the user actions, and the create dialog call right at the end. The rollout definition introduces a couple of new things. The two sets of grouped controls are set up using these group definitions, which allow you to bundle a set of rollout controls into a group box. The string after the group keyword is the label for the group. The first has a pick button control called pick curve and a title, pick curve. I've specified a fixed width of 100 pixels for the button. Normally MaxScript will adjust the width automatically to fit the title text, but I have a number of buttons and I want them all to be the same width. Pick button controls let you supply an optional filter function to decide which objects are selectable as the user mouses over them. The filter in this case is the function called shapesOnly, which I've defined here as a local function in the rollout. The pick system automatically calls filter functions when a pick button is active to test each object under the mouse as it is dragged over them, and they're called with a single parameter, the object under the mouse. The function should return true if the object is okay for picking. So I use the built-in isKindOf function to see if the object under the mouse is in the shape class hierarchy. All the 2D curve classes are subclasses of the shape superclass, so this filter will allow any 2D splines or NURBS curves to be picked. Note that I put the function definition ahead of the control that references it.
This is actually necessary so that the correct function is used. It's similar to the need for declaring local variables before you use them, and actually applies throughout the rollout, so controls have to be defined before their handlers, and so on. These declaration order requirements lead to a common ordering of elements in a rollout.
First, locals, then functions, then UI controls, and finally all of the event handlers. The chain parameters group contains a couple of familiar spinners for the diameter and the thickness, and a color picker swatch for the chain's wire color. I've indicated that the swatch should be center aligned in the dialog with the align:*center parameter here. Below the groups is the create button. I've set it to be disabled when the dialog is first opened and will enable it when the user picks a controlling spline. The first event handler is for the pick button picked event, and it's called when the user picks an object. It is given the picked object as its argument, so the handler saves that away in a rollout local so other handlers can work with it. It also sets the text of the label under the pick button to the picked object's name and enables the create button, since we now have the controlling spline that the chain create code needs. The create button handler makes the chain out of toruses placed and oriented along the spline. It uses the spline interpolation functions we've seen already to walk along the spline a link at a time to get the right position and direction to place each new link. Recall that the spline interpolation functions take a fraction along the curve parameter in the range 0 to 1. So the first thing to do is to figure the parameter step corresponding to a link. It does this by dividing the link diameter value in the diam spinner by the total length of the curve, which we can get with the built-in function curve length. But since we want the links to overlap so that they truly interlink, I reduce the step distance by the link thickness. The interpolation parameter in uStep is then used to step the loop variable u from 0 to 1 along the curve, and the loop body gets the position and curve tangent vector at those successive values of u using the length interp and length tangent built-in functions. These are used to position and initially orient a new torus object, created here with its radii derived from the diameter and thickness spinners, and wire color from the swatch control. The dir parameter sets the rotation of the object so that its local z-axis is pointing along the given direction vector, basically the same way a look-at constraint controller works. At this point, the torus is ringing the curve, since the torus created in MaxScript has its z-axis pointing up through its center hole.
We need to rotate it further to make it lie along the curve, with successive links lying alternatively flat, then vertical, and so on. To make it lie flat, we need to rotate it 90 degrees around local x, and to make it lie upwards, we need to rotate it 90 degrees about local y.
So, I have a 90 degrees rotate function call here, prefixed with a coordsys local to make it use the object's local axes. This if expression is used to select the axis to rotate around. If the variable up is true, then it chooses the y-axis. If it's false, it chooses the x-axis. I make it flip backwards and forwards between true and false as it repeats the loop by using the not operator in this assignment. Up is initialized to true up here at the beginning. Then each time around the loop, the not operator down here makes up false if it was true, and true if it was false. So it'll flip back and forth as the loop repeats.
Well, this is pretty neat, but it suffers from the same limitation as the first sphere creator tool example. You have to delete and recreate the geometry in order to modify any of the parameters. It would be better if the new chain adjusted itself on the fly as the user twiddled the spinners.
So here's a reworked version that does this. Let's run it. Control E. And it looks the same as before, except that the Create button has been replaced with a Delete Chain button. That's because the chain is now created as soon as you select the controlling spline. Let's do that. And yes, here's the chain. Now if I adjust the spinners, the chain links adjust in size and reposition themselves dynamically to stay interlinked. Notice that links drop off the chain if it gets longer than the spline, and are added if it gets shorter. As with the interactive version of the sphere creator, the basic approach here is to grab the created objects into an array and adjust them as the parameters change. The original curve parameter stepping loop now also steps along the array of links, adjusting them according to the updated diameters and curve interpolation. As it steps the curve parameter along, it looks to see if there are enough link objects in the array and adds them if not. Then, after the curve parameter loop is completed, the script deletes the links in the array that are off the end of the curve. Okay, let's look at the changes. There's a new local variable called chain to hold the array of link toruses, initially empty. The UI definitions are the same, except for the Create to Delete button switch. The main geometry building loop is now factored into a separate function called updateChain, which is called by 3 of the event handlers to update the chain based on the current parameters. The key things I've added to make the tool interactive are the spinner and color swatch change handlers. This script is getting pretty big now and a nuisance to scroll around. There's a neat way to navigate about large scripts, which I'll show you now. If you hold down the Control key and right-click, you get a pop-up menu of all the elements in your script. So I'll select On Handlers, and then within it, on diam changed, and it takes me straight to that handler. Whenever the user twiddles the diameter or thickness spinners, these handlers call the update chain function to update the chain based on the current parameters. The color swatch change handler is called when the user clicks on the swatch and selects a new color. The parameter to the handler is the new color, which I assign to the wire color property of all the torus objects in the chain array. I've also added an update chain call to the pick button handler, so that as soon as the user picks the controlling spline, update chain will create new links to fit the current spinner values. The new delete button handler deletes all the linked toruses in the chain array and then resets the chain array to be empty. Let's look more closely at the update chain array function. By factoring the geometry building code into a function like this, I avoid having to replicate a lot of code in each of the spinner and pick button handlers and make them simple and easy to understand, as you saw. The function looks similar to the code in the original create button, setting up the interpolation parameter in uStep and orientation toggle in up as before, but adding an array index variable I, which is used to step through the chain array on each iteration of the main loop. The interpolation parameter loop is run as before, based on the step we derived above, so it'll repeat enough times to fit the selected size links along the curve. The loop body first checks to see if there is a link already in the chain array for the current iteration by comparing the running index I to the chain array size. If there is no link in the array, it creates a new torus and adds it to the array. Then it grabs the current link from the array into the local variable t and updates it, setting radii and position and direction from current spinner values and curve position and tangent as before. At the end of the loop, the current array index is incremented to the next element. If you think about it, this is like a for loop with two loop variables, u and I, with I being looped manually. You can use this approach to have any number of loop variables. Once the parameter step loop has finished, there are exactly the right number of links on the chain for the current diameter and thickness settings, so this mop-up loop is run to delete any extras. The variable I at this point indexes the first unnecessary link, so the loop runs a new variable j from I to the end of the current array, getting us the right number of repetitions to delete each extra link, one per loop. The loop body deletes both the scene object and element out of the array using the array delete item method so that the array is always the correct length.
Note that it uses I and not j as the index to delete. This is because the delete item method actually cuts the element out of the array, moving all the elements following down one index position. This means the ith element is always going to be the next element to delete. If I'd used j, I'd miss some elements.